In this session, I will be discussing about the factors affecting the velocity of the enzymes. Object of this session is, at the end of the session, the learner shall be able to describe different factors influencing enzyme velocity. What are these factors? What are these factors? It is hydrogen ion concentration, then temperature. It is temperature. Okay, then enzyme concentration, okay, then substrate concentration, okay, then product concentration, okay, then activators, presence of activators, okay, time, how much time it takes, light and radiation, okay, finally oxidizing substances, oxidizing agents. Okay, so these are the various factors. Now we'll discuss one by one. The first one is pH, hydrogen ion concentration. Each enzyme has got optimum pH. What does it mean, optimum pH? pH at which enzyme velocity is maximal. Okay, so then what happens? So this variation from this optimum pH, either it is decreased or increased pH. So it influences the enzyme activity. Okay, pH has got very much crucial role. The relation between enzyme activity and pH we can show through a graphical form, through a curve we can show it. Okay, one side it is enzyme activity. Okay, then here it is pH. Let us say the pH here it is, you can say 2, 3, 4, okay, 5, 6, 7, okay, 8, 9, okay, 10. Like that. We have the scale is there. So the curve can be shown as a bell-shaped curve. It is a bell-shaped curve. Where we can say the optimum pH here around, this is the optimum pH. So at this pH, this is what we say is optimum pH. Okay, so at this pH enzyme velocity is maximal. So what does it mean? H plus ions influence okay, enzyme activity. H plus ions influence enzyme activity. Okay, so then by altering the ionic charges on amino acids, let us see how does it mean. What does it mean? Normally, enzyme suppose is carrying a negative charge, substrate is carrying a positive charge, then there will be enzyme substrate complex. Then when you talk about the at low pH, what will be the consequence? Okay, enzyme will be protonated. Leads to protonated enzyme. So it cannot combine with the positively charged substrate so that no reaction can take place. At high pH, okay, substrate will be dissociated. So then there is no charge on the substrate. Then it cannot combine with enzyme so that no reaction will take place. Apart from that one, if there is a pH is extreme pH, it is extreme pH, then what happens? So there will be denaturation. Enzyme being a protein, denaturation is taking place. Once the denatured enzyme activity will be low or almost no activity will be there. So all the enzymes will have the same optimum pH? No. The optimum pH is different for the different enzymes. We have many such examples. Different enzymes will be active at the different pH. Let us say here, again, I will draw a curve. Okay, so that is reaction velocity. Okay, then it is pH, say 3, 5, 7, 9, 11. Okay, so let me draw the curves. So here we have like this. Okay, this is the one. This is the another one. This is the another one. Okay, here it is the optimum pH. Here it is the optimum pH. Here it is the optimum pH. It is different for the different enzymes. In this case, this may be pepsin. This is trypsin, digestive enzyme. This is alkaline phosphatase. See, 3 different enzymes have the 3 different optimum pH. The second factor is temperature, very crucial factor. The second factor is the temperature. So, in small and low temperature, small and low temperature range, okay, temperature range, when you increase the temperature, then rate of reaction will increase up to certain limit. Rate of reaction will increase up to certain limit. Why? Why rate of reaction is increasing? Then when you increase the temperature, what happens? When you increase the temperature, so number of substrate molecules having sufficient energy, okay, to cross energy barrier so that reaction can take place. So certain energy barrier they have to cross, okay, so that they can participate in a reaction. So when you increase the temperature, the energy barrier is crossed and leading to the increase in the rate of reaction. Okay. So what happens? If temperature is increased, okay, beyond certain limits, certain allowable limits, what happens? Naturally, the rate of reaction will decrease. Why it is so? At extreme temperatures, denaturation will take place so that enzyme reaction will decrease. Like also, we can draw a curve in case of temperature. This is enzyme activity. Okay, this is temperature. In this, so there is a bell-shaped curve. You can see here, there is also optimum temperature. This is what we call is optimum temperature. Okay. Optimum temperature, 10 degrees increase. Okay, reaction velocity doubles. Reaction velocity doubles. Okay, reaction velocity doubles. Okay, then in the condition, so what we call it is temperature coefficient. Q10, temperature coefficient. We can say temperature coefficient. Okay, this is also up to certain limit. Same thing, if you decrease the temperature by 10 degrees, the reaction will be off. the reaction will be off. When it is increased, the reaction will be doubled. When you decrease by 10 degrees, the reaction rate will be off. At 0 degrees, most of the enzymes are inactive. Most of the enzymes are inactive. The next one is enzyme concentration. Enzyme concentration. Enzyme concentration. So when you talk about enzyme concentration, first I will draw a curve. I will show diagrammatically. Let us see. So here it is enzyme activity. Then here it is enzyme concentration. It is enzyme concentration. What happens? So when substrate is available, the rate of reaction is proportional. So to the enzyme concentration. Let me draw a straight curve. Okay. So it is proportional. So these also some limits are there. One of them is limited, then the reaction will be stopped. It will maintain at that velocity. Okay. Then this is about the enzyme concentration. The next one we are going to take up is a very crucial one. That is, we call it substrate concentration. Substrate concentration. Substrate concentration. Okay, so this is the key factor in enzyme catalyzed reactions. This is a key factor in enzyme catalyzed reactions. This can be represented like this. But it is a key factor affecting the rate of reaction. Affecting the rate of reaction. Okay, then let us see here. Let us understand in diagrammatically. Let us say again. I will draw a diagram showing this curve. Okay, showing this curve. Here it is again as usual. This is reaction velocity. Okay, then here it is initial velocity. This is substrate concentration. Okay, then what happens here? Let me draw for the non-allosteric enzymes and allosteric enzymes. Like this. This is for the non-allosteric enzymes. Whereas, so this one is allosteric enzymes. Okay, so let me say this one is non-allosteric enzymes. Okay, this one is allosteric enzyme. Non-allosteric enzyme and allosteric enzyme. Okay, then here V0 is initial velocity. Here one thing is here. Okay, then this is the maximum velocity. Maximal velocity which can be attained. After that there will not be any increase in the velocity. For a given quantity of enzyme, the velocity of reaction will increase as the concentration of the substrate is increased. Okay, let us try to understand. Taking the substrate concentration. At low substrate concentration, Low substrate concentration. What is the scenario? More enzyme molecules are free. There are more enzyme molecules are free. In that condition, rate will be proportional to the increased substrate concentration. Rate will be proportional. Rate will be proportional to the substrate concentration. Okay. At high substrate concentration, at the high substrate concentration, what happens? Almost all the enzymes are in enzyme substrate complex. If you further increase in substrate concentration, it will not lead to increased rate of reaction. Will not lead to the increase in rate of reaction. So let me explain. Suppose what happens when substrate concentration is low, enzyme molecules are there. So what happens when increase the substrate concentration, the rate will be proportional. Okay, but at high substrate concentration, what happens? All the enzymes are occupied with the substrate. If you further increase the substrate concentration, where are the enzyme molecules to combine with the substrate? So then there is no question of increase in the rate of reaction. That is the reason the curve is the hyperbolic curve. Okay, shape of this enzyme kinetics curve. Shape of this enzyme kinetics curve will follow Michaelis-Menten kinetics. Michaelis-Menten kinetics. Okay. So, this hyperbolic curve. Whereas, allosteric enzymes, they do not follow these kinetics. They do not follow Michaelis-Menten kinetics. Okay. Then, so here other aspects of the enzyme kinetics are there that I will take up in the next session. Here simply you have to understand V maximum and substrate concentration, velocity. But one thing I would like to say, there is a Km. Michaelis constant. What does it mean? Km means substrate concentration at which enzyme velocity, the rate of reaction or enzyme velocity is of maximal. In other way, 50% of the substrate and enzyme combination, enzyme substrate complex is there. That is as simple as that. That I will discuss in detail in one of the sessions. Okay, then. The next one is effect of product concentration. Effect of product concentration. What does it mean? Let me explain. Suppose enzyme plus substrate leads to enzyme, substrate complex, then enzyme plus product. So what happens when there is an accumulation of these products? When there is accumulation of products, then what happens? There are no free enzymes. When free enzymes, accumulation of product, there are no free enzymes. Then what happens? The rate of reaction will decrease. Rate of reaction is decreased. Suppose if you take in digestion process. In the digestion process, some enzymes will be there. They will be acting on the dietary substances. But what happens? Immediately those products will be removed from the site and absorption will take place so that enzyme reaction will be continued. If that doesn't take place, enzyme reaction will be stopped. So products are to be removed so as to continue the enzyme reaction process. The next one is effect of activators. In enzyme catalyzed reaction, the presence of enzyme and substrate are not the only requirements. There are many other requirements are there. One of such requirement is some activators, metal activators. Some example, what are these? Mg2 plus, okay, Mn2 plus, okay, then Zn2 plus, then calcium 2 plus, cobalt, okay, here it is cobalt, then copper, okay, then sodium and potassium, okay. So they require for this enzyme activity. These various factors they require for enzyme activity. These factors, maybe we can say, these factors can be segregated into metal activated. The enzymes taking these factors, they can be segregated metal activated enzymes and metalloenzymes. What does it mean? Metal activated enzymes, metalloenzymes. Metal activated enzyme means metal not tightly bound with the enzyme. Tightly bound with enzyme. It is not the integral part of the enzyme. Okay, suppose if you take ATPase enzyme, it requires Mg2 plus or calcium 2 plus, but they are not tightly bound. Removal of these factors will not affect the enzyme. Enzyme will not be destroyed. Enzyme will not be destroyed. Metals tightly bound. In these metalloenzymes, metals tightly bound. That means removal of this metal from this enzyme will denature the enzyme, will affect the enzyme structure. Okay, so alcohol dehydrogenase, it contains zinc 2 plus. Okay, carbonic anhydrase, it contains, okay, carbonic anhydrase also contains zinc. And ALP, also alkaline phosphatase, also contains zinc. Phenol oxidase contains Cu2 plus. Okay, then the xanthine oxidase contains molybdenum. Okay, this is about the role of metals in the enzyme activity. The next one is effect of time. Effect of time. What does it mean? Suppose ideal and optimal conditions are there. So in that condition, to complete time required to complete the enzymatic reaction is very, very low. Time required for an enzyme, okay, reaction is less. Enzyme, okay, reaction is less. If any of the factors are not present in a required quantity, then more time will take. That means optimum conditions will increase the enzyme reaction so that less time will be taken up. The next one is, okay, effect of light and radiation. Effect of light and radiation. What does it mean? Effect of light and radiation. Suppose when you take the UV rays, in the presence of UV rays, beta and gamma rays, so what happens in this condition? So inactivates the enzymes, inactivates enzyme. Okay, so this is about the effect of light and radiation. Finally, okay, effect of oxidizing agents. Effect of oxidizing oxidizing agents. Okay, when I talk about the effect of oxidizing agents, so many enzymes at the active site, enzymes means contain amino acids. Many amino acids, that means cysteine, methionine, those amino acids, they contain at the active site, what is that group? SH group. SH group. Suppose if SH group is oxidized, SH group is oxidized, then what happens? The active site will not be proper. In that condition, what happens? The activity of enzyme is decreased. Let me show it. Suppose this is the enzyme. This active site contains reduced sulfate groups. Suppose in the presence of oxidizing agents, then what will happen? Oxidation takes place. Then what will happen to the active site? The active site is gone. The active site is changed, so that no reaction will take place. So that is the reason glutathione like reducing agents are necessary to keep these sulfide groups in a reducing state. Okay, these are the various factors which affect enzyme catalyzed reactions. In this session, we have discussed about the various factors affecting the velocity of enzymes. Let me summarize it. Various factors which can affect enzyme catalyzer reactions. These are pH, temperature, concentration of enzyme, concentration of substrate, concentration of products, activators, time, light and radiation, oxidizing agents. Let us summarize one by one. Okay, pH, hydrogen ion concentration, decrease or increase pH affects the rate of reaction. Okay, it is a bell-shaped curve between rate of reaction and pH. Every enzyme at the optimal pH will show the maximal velocity. Okay, extreme pH, so denaturation takes place, velocity is decreased. Optimum pH for different enzymes is different. Okay, you can see in this diagram, pepsin will have the different optimum pH, trypsin will have the different, and alkaline phosphatase will have the different optimum pH. Second factor is temperature. If there is increased temperature, rate of reaction will increase. That will apply to up to certain temperature. Okay, when there is increased temperature, substrate molecules attain high energy state to cross the energy barrier, so that the reaction can take place, products are released. See here also bell-shaped curve, reaction velocity and temperature. Okay, so here also at particular temperature, enzyme velocity is maximal. Okay, generally that is around the normal body temperature. Okay, then extreme temperature will lead to the denaturation, rate of reaction will be decreased. So there is one aspect is there is temperature coefficient, so that is Q10. Every 10 degrees rise in temperature, the rate of reaction will become double up to certain temperature. Every 10 degrees decrease in temperature, the rate of reaction will become 50%. Okay, so next one is the concentration of enzyme. If sufficient substrate is there, excess substrate is there, if you give the more enzymes, the rate of reaction will increase. It is a proportional. Okay, if there is no limit of the substrate. Okay, then concentration of the substrate. It is one of the most important factors. So here the reaction velocity, substrate concentration. Okay, when you increase the substrate concentration, the rate of reaction will increase up to certain level where enzyme molecules are available. After that, even if you increase the substrate concentration, the rate of reaction will not be changed. When there is increased substrate concentration, rate of reaction will be increased. So let us see at low substrate, velocity is proportional. Velocity is proportional. Here you can see at low substrate concentration, velocity is proportional. When there is a high substrate concentration, okay, velocity reaches the maximum, V maximum. After that, even if you increase the substrate concentration, there will not be further increase in the rate of reaction. It follows the Michaelis-Menten kinetics. It is a hyperbolic curve with reference to the non-allosteric enzymes. Allosteric enzymes will have the sigmoidal shape. Allosteric enzymes do not follow the Michaelis-Menten kinetics. Okay, so then the next one is the concentration of products. The accumulation of products will decrease the rate of reaction. Why it is so? When enzyme and product in combination, there are no vacant enzyme molecule, so they cannot bind the substrate. That is the reason the rate of reaction will decrease. That is where the significance of absorption after the digestion process. In the digestion process, enzymes will act, but those products will be removed through the absorption process so that enzyme molecules will be vacant. So more substrate molecules can be taken out. Okay, then effect of activators. The presence of enzyme itself is not sufficient. Coenzymes, cofactors are required for any catalyzed reaction. Okay, enzyme cannot act alone. It will have to have some assistance in the form of coenzyme or cofactors. Okay, there are metal cofactors are there. They activate the enzymes like magnesium, manganese, zinc, calcium, cobalt, copper, sodium, potassium, many. So these can be divided into metal activated and metalloenzymes. What does it mean? Metal activated. Metal not the integral part of the enzyme. Metal is not integrated part of the enzyme. If you remove the metal, enzyme will not be destroyed. Whereas in case of metalloenzymes, metal is the integral part of the enzyme. If you remove the metal, enzyme will be destroyed. Okay, the time I'm discussing in a sense how much time it takes for the particular catalyzed reaction. It depends upon if the reaction is conducted under optimal conditions, less time is required to complete. If there are no optimal conditions, more time will be taken up. That is what I wanted to convey. Next factor is the effect of light and radiation, especially radiation. Okay, if there is an exposure to the radiation, UV radiation, denaturation will take place, velocity will be decreased. Okay, then the next one is effect of oxidizing agents. Enzyme, there is a catalytic site is there. Some important amino acids are there, like sulfur containing amino acids. So there are the sulfhydryl groups are there in reduced state. If they are in the reduced state, then only they can bind the substrate. So that time we can say enzyme is active, but in the presence of oxidizing agents, so they are in oxidized state, so that it is converted to inactive. It cannot bind with the substrate. It cannot bind with the substrate, so that enzyme becomes inactive. So in that sense, the presence of reducing agents very, very important. Glutathione is one such reducing agent. Okay, these are various aspects of the factors affecting enzyme catalyzed reaction. Okay, thank you very much.